Here we are presented with the stellar data. That means we are given a table of a star whose absolute magnitude MV is the absolute magnitude. This is the absolute magnitude. A small MV is the apparent magnitude. Then we are given the spectral type and the luminosity class. From all this information, from all this table, we need to answer many questions here. For example, which star appears brightest? Which star appears faintest? What is the main sequence stars? What is the temperature? Which star has the longest lifetime? Which star has the shortest lifetime? Which star has burned their energy or the fuel? So we can answer all these questions just from this information. And in addition, we can also determine the size of the stars. So let's look into the data and find out or extract the information from this stellar data. Before jumping into this one, I would like to talk about what this absolute magnitude, apparent magnitude, spectral types, and the luminosity class stands for. So I'll just give you a brief introduction of all this information. So as I mentioned here, this column here is the absolute magnitude. This is apparent magnitude. So let's find out the differences here. First, the apparent magnitude, this MV, a small MV. So this tells you how bright a star looks like when you see from the Earth, or when you look through a telescope, how bright it looks like. So again, this is an apparent because it is all the measurements are done from the Earth. And how bright it appears to your eye is the apparent magnitude. So the least negative numbers or the most negative numbers, mean it appears brighter in the sky. For example, just look at this table here. Which one is the most negative? The most negative number here is 1.4 here. From this table, that means when you look in the sky from the Earth's surface, then the Sirius appears more brighter than any other stars in this table here. And which appears faint or dimmest, so which has the most positive value. So look at this table here, and from this table we see that the Regulus has the most positive value of 1.4. That means when you look at the sky through your eye or even through a telescope, then this star appears the faintest in the sky. Again, from all these stars, the Regulus appears most faintest star in the sky. Okay, if a star is the faintest, does it mean that it is not luminous? So a star could appear much brighter or dimmer, but it doesn't mean that it is actually more bright or less. What does that mean? That means, now let's say you are on the Earth's surface here. Here, let's say this is our Earth surface here. Let me draw a better picture. So this is Earth here. And let's say we have a star here. And then there is another star here. Okay, when you look from the Earth's surface, as this star is closer to us, it might appear that it is brighter, but in reality, this star could be way brighter than this star. The reason is this star is a lot farther from this one. Okay, but to our eyes, if this star appears more brighter, that means the apparent magnitude of this star is smaller if it appears more brighter. But how about the luminosity? So how do we calculate the luminosity or the absolute magnitude? So if all the stars, so how do we measure the luminosity here or the absolute magnitude? If all the stars, now let's say this star and this stars, if all the stars were exactly at the same distance, now let's say here, if all the stars, if I place both the stars, this star and this star exactly at the same distance, then the star which appears more brighter will have, or then that will give you that in that case. So all the stars are now presented exactly at the same distance, and in that case the apparent magnitude would be the absolute magnitude. Okay, so absolute magnitude is the apparent magnitude when all the stars are presented, or when all the stars are at a distance of 10 parsec here. If all the distance are brought at a 10 parsec, then the apparent magnitude in that case would be the absolute magnitude. Okay, so in other words, just for our understanding, the absolute magnitude tells you the luminosity of the star. This tells you the luminosity. Just make a note of all these things here. Luminosity, again, what is the luminosity means? The luminosity means how much energy it is radiating into the space is the luminosity. So this tells you the energy emitted by the star per second. By the stars, okay, per second. Okay, so from this information, how do you calculate again? So again, just look at this table here, and the stars with the least or with the most negative number will be the most brightest in the sky, or in fact it will be more luminous. So of these tables, what I see here, the Antares has a value of minus 4.5 absolute magnitude, and as I say, the more negative means more brighter it is. So this star would appear more brightest, or in fact it is more luminous than any other stars in this table here. And this star here, Alpha Centauri, has a most positive value. The most positive value, that means if you look in the sky, or this star in fact has the less luminosity. That means it is emitting much smaller energy than any other stars in this table here. So that this is the meaning of absolute magnitude and the apparent magnitude here. The most negative means more brighter, the more positive means a small brighter. Okay, let me write down here. More negative, more brighter. More positive, less brighter. That happens for both absolute magnitude and apparent magnitude. In fact, this would tell you the luminosity and this wouldn't tell you the apparent magnitude. Okay, now let's talk about the spectral type. A spectral type. What is the spectral type tells you? The spectral type here in fact gives you the information about the temperature of this star. This tells you the temperature. And luminosity class, this tells you about the size of the star, how big the star is. Size of the star. Size of the stars. Okay, so let's answer all the questions here. So the first question is, which star appears? Look at the term here. What is it? Which star appears brightest? So how do you find out when it says appears? That means you have to look for the apparent magnitude here. And as it says brightest, that means you have to look for the most negative number. So look at the most negative number here. So the most negative number I see here is the Sirius. The Sirius has the most negative number. That means this star appears brightest in our sky. Okay, the second question, which star appears? Again, appears. That means you have to look for the apparent magnitude in our sky. So in order to look for the faintest sky, you have to look for the most positive, the apparent magnitude number, most faintest. So most faintest means more positive. The more positive is Regulus. So this has the most positive number. That means it appears the faintest in the sky. Which star has the greatest luminosity? So again, whenever you see the term luminosity, that means you have to look for the absolute magnitude. Absolute magnitude. That means more the negative number is, more the luminosity it will have. Most negative numbers. So look, you have to now look for this table here, because it is talking about luminosity. This is luminosity. So most negative number. So out of all this, the most negative number that I see is Antares. This number here, negative 4.5. So it is most luminous star in the sky. Okay, so we got this answer too. And now, which has the least luminosity? Again, what do you look at now? The least luminosity means, again, you have to look for the absolute magnitude. Absolute magnitude, okay? And as it says the list, the list means you have to look for the most positive MV. Okay, so most positive. So most positive from all this table is Alpha Centauri A. Okay, so look at the answer. We got the answer here too. The Alpha Centauri A is the most luminosity because it has the most positive absolute magnitude. Again, absolute magnitude here is MV. Now, how about the next one? Which star has the highest surface temperature? Remember, how do you get the star surface temperature information? This column here, this column tells you the star surface temperature. That is spectral type. Okay, so how do I know that which one has the highest temperature? So okay, so here is the answer. You have to know this word here, OBAFGKM. So you can remember this mnemonic by O, be a fine girl, kiss me. So if you know that, then you should be able to tell the surface temperature of any star. How do I know that then? So O, the spectral type O means highest temperature, and the star which has a spectral type M means the lowest temperature. So that means if I go from this way, O to M, then the temperature decreases. Temperature decreases. So what is the question? Which has the lowest surface temperature? So what do you have to look for now? The lowest surface temperature means I have to look at the star whose spectral type is M. The spectral type M. So let's go here. The spectral type M. So here I see only one here, M1. So M1, that means this one has the lowest surface temperature, and Taurus has the lowest surface temperature, and the reason is it is a spectral type M. Okay. It is asking for the highest surface temperature, but we got this answer now. The lowest surface temperature is M1, and the highest surface temperature, how do you calculate the highest surface temperature? You have to look for the stars with O type. Let's see if there is any star of O type. I don't see any star of O type. Then what is next then? Is B. We do not have any star of O type. Then look at the star with the B type then. The next is the B type. So here, oh, I see the two B types now. B1 and B7. Lots of confusion, right? Yes. So if you have the stars B1 and B2 of the same spectral time, then B1 would have more surface temperature than B7. Okay, so B1 temperature will be more hotter than B7. So the answer for this one will be a spica or a spica, whatever you call. Okay, so remember, I'll just write down. So B1 is the surface temperature is greater than B7. Here temperature, I'm talking about the temperature. If they have the same spectral type, then the lower number means again the higher temperature. Okay, so we got the answer for this one. This question, we got the answer for this question. This next question is, which star is most similar to the sun? We do not have a sun here. We do not have a sun here, but we have the information about the sun. So look at the sun here. So this is the HR diagram, and if you look at the sun, our sun is right here. That's the sun here. The sun is a spectral type G. Sun is a spectral type G. Okay, and the luminosity is about 1. It is all the luminosity are measured with respect to the luminosity of sun. So the sun is G type, a spectral type is G. Okay, so the one information we know about the sun is spectral type G. And here I have not talking about the stellar luminosity of the classes. So here it's given here the luminosity classes. So what does this mean here? The luminosity classes tells you the size of the star. So here what is mean? If the stellar luminosity class is 1, the Roman 1, that means the star is super giant. It's so big, so big. And if you keep going, if increasing, that the size decreases. This way the size decreases. And also remember this line here, our sun lies on this line here, or on this train here. This is called the main sequence. Main sequence here. Okay, so the star that are closest to the sun would also has to be onto this line, that is the main sequence star. Okay, so how do we find out the main sequence star? All the main sequence star have the luminosity class, the V or 5. Let's call V here. Okay, all the luminosity, all the main sequence star is the V star. Okay, so now let's go back to the table here now, the V star. So we have, how many we have V stars here? One is Alpha Centauri, the other is Fomalhaut, Regulus, Sirius, Spica. So we have 5 V types of stars. So again, confusion, which one would be more closest to the sun? Then the next thing we'll look is the spectral type. Remember here, the spectral type, the sun is a spectral type G star. So okay, now let's narrow down our selection here. So all these stars are the main sequence stars, but which one is a spectral type G? The only one which is a spectral type G is this star here, Alpha Centauri here. This is the main sequence star, and this tells you is the spectral type G. So this star is closest to the sun, okay, because of the luminosity class and the spectral type. Okay, so we got the answer for this one too. Okay, sun, here all the answers are described here, so you can pause the video and look at the explanation. In the table, no, I think there are not 2, I think there are 5 of them. So this is my mistake here. I think there are 5 stars of the same luminosity class. So the next thing we're going to take a look is the spectral type. Sun is a spectral type of G, and the other only star with the spectral type G and the luminosity class V is the Alpha Centauri. So we have already chosen our option. Okay, let's move on then. So we have all our answers almost. Which one is the red supergiant? Red supergiant. So how do we get this information? Remember the luminosity class. Here I already have given you the table here. This table. The supergiant, it tells you. The supergiant means the class must be I class or the 1 class, I class. So look at the table here. Which star falls into the I class here? So we have to look at the luminosity class, and the only 1 class or I class the star falls is Antares. So this is the supergiant. But why do we call the red supergiant? We call the red supergiant because from the spectral type, if you look at the spectral type, it is M-type star. The M-type means red. So remember here, or you can look at here, the M-type just tells you the red here. And O-type means blue, M-type means the red, okay? G-type means yellowish, like sun. So we know our answer here. Which star is a red supergiant? The red supergiant must be luminosity class I, okay? And it has to be a spectral type M1. So the only thing we have is Antares. Now, which star has the largest radius? How do you get this information? The largest radius, again, the largest radius means it is a supergiant. The supergiant here. So how do I know again the supergiant here? The supergiant star has a class I. So look at the table here. The only star that is supergiant in the luminosity class I is the Antares. So our answer is Antares. So okay, so we got this answer too. What is the next one? Which stars have finished burning hydrogen in their cores? So in order to explain this one, I will come back here one more time on the HR diagram. So if you look at this HR diagram, this is called the main sequence stars here. All the stars that lie onto this line here is called the main sequence. So the main sequence, the reason we call main sequence is because all the stars in this region still have the energy or the fuel to burn, or it is still changing hydrogen or burning hydrogen into the helium. So it has, and that's the reason we call it as a main sequence of stars here. And all the other stars here in this region which are not the main sequence star have almost lost their fuel. So only these stars are still burning their hydrogen into helium, and all other stars have nearly lost their lives or about to lose their lives, okay, or have not much energy left, or we can call that in the dying stage. So look at how do we identify the main sequence star? The main sequence stars falls under the stellar class V, and all these other stars which are not the main sequence stars, must be in the dying stage or have burned their fuel. So look at the table one more time. So I have this as a main sequence, this is the main sequence. So all these are the main sequence star. So these are the main sequence star. So this means these stars are still burning their hydrogen into fuel, or burning their fuel, so still have much fuel left. But all other stars, for example, Aldebaran, Antares, Canopus, so all these stars are not the main sequence star. What does that mean? That means it has almost lost their lives, or in other words we can say it has almost burned their fuel. So you have the answer here. Okay, here is the answer, because these stars do not fall into the main sequence line, so that means they have burned their hydrogen cores. Okay, now among the main sequence star, which is the most massive? Okay, let's take a look here. So we have the main sequence stars here. So this is the main sequence star, and which one is more massive? How do we know that which one is more massive? So the stars on this main sequence star, the stars with the highest luminosity means it has more mass. Again, because the luminosity means it is emitting more energy. Okay, so I'm just only talking about these stars here for now, the main sequence star. Okay, the luminosity means radiating more energy. And when can it radiate more energy? A star can radiate more energy when it has a larger size, or bigger size here, more, or in other words we can say the more mass. Bigger size means more mass here. So on the main sequence stars, on the stars with the highest luminosity means it has more mass. And when it can have the highest luminosity means it has a smaller or most negative MB, that is absolute magnitude. Okay, so look at one more time the question. Among the main sequence star, which one is most massive? Okay, so let's come back here on the table. First, we have to find out which are the main sequence star. Everyone ready to find out the main sequence star? The main sequence star have the class type V. So these are the main sequence star. Here. And now, which one is more massive? So the more massive will be with the more luminous. And how do we do that? Of these four, which are more luminous, that means the most negative number will tell you the star with the most luminous star. So look at the smallest negative number here, a Spica. Let me choose a different color for this one. A Spica here. So a Spica has the most negative number. That means it has the most luminosity. So that means it has more mass compared to the others. Okay, so we got the answer for this one too. all the explanations are written there too. So stop the pause the video and you should be able to see the all the explanation. Now among the main sequence star, which has the longest lifetime? Now it's talking about the longest lifetime. So the longest, so again, it's talking about the main sequence stars here, main sequence stars. So we have all the main sequence star here. And among all these main sequence stars, we have to find out which one has the longest lifetime. Longest lifetime. So I'll just write down a note. The most negative, let me use a different color. Most negative MV, or the absolute magnitude, means more luminous, and more luminous stars means less lifetime. So all the stars which are main sequence star, if it is more luminous, then that means it has the less lifetime. So a Spica, again, if you look at here, this is the most luminous main sequence star. That means it has the less lifetime. Oh, it is asking about the longest lifetime. Okay, so this one has, okay, so this one has the most lifetime. And the least lifetime, sorry, my bad, this has the least lifetime because it is most luminous. Least lifetime, because it is more luminous means least lifetime. And this is the, now look at here, this one Alpha Centauri here is less luminous. This is less luminous. So what does this mean? Less luminous means more lifetime. All right. Okay, so Alpha Centauri. And if you want to know why the main sequence star with the most, or why the most luminous main sequence star have a less amount of time or less lifetime, you have to watch my other videos and I'll post it. But again, just go step by step. And again, if you have any questions, you can ask me. Before doing that, I will have one more thing here. So you can look at this table here too, or this HR diagram. So what does this HR diagram tell you? So this is the main sequence star here. And you can clearly see the stars here. These are the less luminous. And these are the more luminous. If it is more luminous, then look at the lifetime. The lifetime is 10 to the 7 years. And this is less luminous. That means the lifetime is 10 to the 11 years. So these stars have more lifetime than the most luminous life star. Okay. So this is it from this video. Again, if you have any questions, write to me. And do not forget to like, share, and subscribe the channel. Thank you.